Today's lesson is about chemical compounds. Chemical compounds are formed from two or more elements held together to create a compound. Most of you recognize compounds in shorthand. For example, water is known as H2O. Ordinary table salt is known as sodium chloride, written as NaCl. These are examples of compounds written as people commonly know them, but they are still made up of two elements held together by a chemical bond. Chemical bonds are created by atoms being held together by one particular subatomic particle. That particular particle are electrons. The outermost electrons, which is known as the valence electrons, are what create the chemical bond. To review, the chemical bonds are held together by electrons, which are on the outermost electron clouds called valence electrons. As you can see here, this is a picture of an electron cloud. You have the nucleus in the center where your protons and neutrons will be located, and each one of these separate levels, also known as energy levels, also known as electron clouds, will have different levels where they can hold different amounts of electrons. This is the second level, this is the third one. Energy can be held, absorbed, lost, or transferred from these actual clouds. The outermost part of the electron cloud, which is this outside one, is also known as valence electrons. These valence electrons are what is going to create your different chemical bonds. As you can see in this picture, in the first electron cloud, written here as the first orbital, it holds up to a maximum of 2 electrons as seen on this cloud. The second orbital, as you see right here in these pictures, hold up to a maximum of 8 electrons. And as you can see them, 1, 2, 3, 4, 5, 6, 7, 8 total electrons. This picture of the periodic table shows the number of electrons within their electron cloud. Since the atomic number of hydrogen up here is only 1, there's only 1 electron. As you start to look at other elements that have higher atomic numbers, meaning that they have more protons and electrons, for example, carbon will have an atomic number of 6, and as you can see here in the first cloud you see 1, 2, and then the last cloud you see 1, 2, 3, 4. Remember, 4 plus 2 equals 6. Same thing here with your nitrogen pointed out by this arrow. There is the 7th electron because the atomic number is 7th. And the numbers keep increasing as you go through the different elements, with oxygen, fluorine, to neon. There are two main types of chemical bonds that you're about to learn about. What are they? The two major types of chemical bonds are ionic bonds and covalent bonds. Now, these are not the only two types of chemical bonds, but these are the two major ones, and these are the two that we'll be concentrating on today. First, we'll begin talking about ionic bonds. Ionic bonds is when the outermost electron, known as your valence electron, is transferred from one atom to another. When this happens, a bond is created known as an ionic bond that holds those two elements or atoms together to form a molecule. Now, when this happens, the atom that loses an electron will become positively charged, because remember, an electron is negatively charged, and if you lose one electron, there's now going to be more positive protons than negative electrons, leaving a net of a positive charge. Now, for example, for the opposite side, the atom which gains the electron will gain a negative charge, because this is now gaining an extra negative electron, which will net extra negative energy. And to title these negatively or positively charged ions, an electrically charged atom is called an ion. These next few slides should give you a very good example of how an ionic bond works. First, we'll start with sodium, example or symbol Na, as you can see right here. Sodium has an atomic number of 11, which means it has 11 protons. Also, we'll have 11 electrons. We will point out that you can see 1, 2 on the first cloud, because remember the first cloud can only have a maximum of 2 electrons. The second cloud can have a maximum of 8. We can count them: 1, 2, 3, 4, 5, 6, 7, 8, making 8 plus 2 is 10. And now the 11th electron is right here. Remember, the electron that is on the outermost cloud is what's called your valence electron. As we now follow this ionic bond being created, this extra electron, which was right here, this valence electron, is now going to be transferred over to chlorine. So you can see chlorine is represented by Cl. Now, if you notice, chlorine has an atomic number of 17, which means that there is one less electron on its outermost cloud. It only has 7. 1, 2, 3, 4, 5, 6, 7. And it wants to find that last electron. So the easiest way for it to happen is for it to steal it from another element or atom that is close by, forming a bond between these two elements. This arrow represents, as you can see, these two atoms about to form a bond together. And if you notice now, the outer cloud on sodium is now missing, where the excess or the extra electron is now along the chlorine outermost cloud, creating a maximum of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And you see the final product now, which is sodium chloride, which is sodium and chlorine combined together. You should also notice that there is a positive symbol next to sodium and a negative charge next to chlorine. That's because one extra electron that used to be on the outer cloud out here on sodium is now with chlorine. So even though there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons outside here that are negative, there is still a remainder 11 protons inside of sodium. Now with 10 electrons. So there's one more positive proton than there is negative electron, netting an additional 1 proton, making this particular sodium ion positively charged. And in the opposite, chlorine right here is going to have an additional negatively charged electron, creating 18 electrons, which again are negative, but there's still remainder 17 protons, which is positive, netting and 1 extra electron, which will mean there's 1 extra negatively charged ion, creating chlorine becoming negative. And remember, positives, negatives attract, creating what is known as an ionic bond. If you still do not understand, please ask your teacher for help, and I will gladly come over and explain it. When all of these electrons are completely transferred, which happens almost instantly, you get this cluster of elements formed together, which creates this in real life, which is an ordinary little grain of table salt. Now the other type of bond is known as a covalent bond. Now instead of one element stealing an electron from another one, this is when they will both share the extra valence electron. Now again, a covalent bond is when electrons are shared between atoms. Now, when you have two electrons being shared, this is known as a single covalent bond. When you double that and you have 4 electrons being shared, this is a double bond. And finally, when you have 6 electrons, this is called a triple covalent bond. When structures that result from atoms being joined together by a covalent bond, this is what's commonly known as a molecule. Molecules are some of the smallest units of compounds. Molecules tend to be more of smaller molecules like water and salt, or compounds tend to be much longer, things like sugar. Here is an example of a simple covalent bond, which is known as water. You can see these 2 electrons being shared between hydrogen and oxygen here, and here is another covalent bond being shared between this hydrogen and the same one particular oxygen molecule. And that is how water is created, from hydrogen and oxygen being held together by a covalent bond. Now, the last type of chemical bond we'll talk about is known as a van der Waals force. Now, these are when molecules are close together. There's always going to be a slight attraction between oppositely charged molecules. Now, this will not create as strong of a bond as there is between an ionic or covalent bond, but this will still hold some chemicals together. And this is known or created by the man or the gentleman who discovered this, known as the van der Waals forces. Although van der Waals forces are not as strong as ionic bonds or covalent bonds, they can hold molecules together, especially when a molecule is very large. An example of a van der Waals force occurs underneath the foot of a gecko. As you may or may not know, geckos have the ability to walk straight up walls. This is because the molecules that make up their feet will form a type of van der Waals force with the molecule of the surface of the wall, allowing them to grasp onto a flat surface and walk vertically straight up a wall, where sometimes you may commonly see them if you are further down south in the warmer weather. Same thing like with salamanders.